Hi guys, for today's video we're going to be dealing with the derivative of a power of x. So last lesson we learnt that you could use first principles to figure out the derivative of a function, but finding the derivatives of functions can be done more simply compared to this first principles method. There's a simpler way to do it, and this is the rule that you need to take in that shows you this simpler method. So let f of x be some sort of function where x is to some sort of power. So we've got a base of x and it's being powered. The derivative is going to be equal to this formula right here. So f dash of x is equal to n, that's literally just this power here, it's come to the front and is multiplying. The x base stays and the power of x goes down by 1. It's n take away 1. So whatever this number was, the power is going to go down by 1. So for example, if you've got the function f of x equals x to the power of 5, that 5 right there is going to come to the front and multiply, and this power is going to go down by 1, and this base stays the same. If you've got, say, f of x to the power equals x to the power of negative 3, that negative 3 is going to come to the front and multiply, as you can see here, and this power is going to go down by 1 to negative 4. We do like to simplify negative powers, so the x gets pushed down to the bottom with a positive power of 4. The negative 3 isn't like that isn't affected by the negative 4 power, so that negative 3 is going to stay up the top. Next up, say if f of x is just x. The derivative of just an x by itself, well, the idea is that this 1 can go to the front, and that 1 will go down by 1 and it will change to a 0. So the 1 goes to the front, the power changes to a 0. Anything to the power of 0 is 1 itself, so 1 times 1 equals 1. So the rule is that pretty much the derivative of just x is going to be just the number 1. If you've got f of x of just some sort of constant like 7, we can think to ourselves that 7 is the same as 7 times x to the power of 0. We need our x to kind of use this rule here. The 0 can come to the front, so we've got 0 times that 7, and the 0 will change to a power of negative 1. But literally anything multiplied by 0 is going to equal 0. So rule of thumb, whenever you're dealing with some sort of constant, like 7 or 50 or 8 or negative 20, the derivative of those sorts of functions is going to be equal to 0 always. Note, this is a really important note here, that if you've got some sort of function f of x and you've got two expressions that are adding together in terms of x, all you have to do is take the derivative of both of those expressions and add them together. So the idea is that when you've got expressions that are adding together and you've got to differentiate the whole lot, don't worry about it. Just differentiate each part separately and it's fine, and that's the way you can do it. Plussing is really nice for differentiation because you can just look at each part separately and you don't have to worry about any issues arising. If that was, say, multiplication, however, it'd be a different story. Another note down here, if you've got a function where you've got an expression that's in terms of x, and that expression is being multiplied by a constant, by a whole number, make sure it's a number. You don't want to see any x's or anything in there. Again, don't worry, just deal with this expression in terms of x, differentiate that, and at the end you can multiply it by that constant. That constant literally will not change. So don't worry about if there's a constant thrown in front of it, some sort of expression with x's, etc. So let's do some examples with this. So you can see here that our function is x cubed plus x to the power of 4. So we've got an expression here and an expression here. Just differentiate both of them separately because you've got this plus in between. Pluses are really nice for differentiation. So we get this one here becomes 3x squared, and this one here becomes 4x to the power of 3. This one here, again, not too bad because all we've got here is this 5, this constant multiplying, and constants that are multiplying are completely okay. Just look at your part inside your bracket and differentiate that. That part there becomes 3x squared plus 4x cubed, as we did just here. And we can just literally leave that 5 alone. We can just keep it out the front of the brackets. And lastly, we do like to expand our expressions. So we get 15x squared, and then we get 20x to the power of 3 for our final answer. Next one is this sort of function, 4x cubed. Again, that constant out the front, don't worry about it. You can just leave it and just deal with this part here in terms of x. If you differentiate that, you get 3x squared, and you just got to make sure you just keep your 4 where it is, and that's multiplying. So that's going to make 12x squared, if that makes sense. Another way you can do it is literally bring that 3 to the front and multiply it with the 4, and you get that 12, and that power of 3 is going to become a power of 2. So there's a couple of ways to do that sort of one. Okay, let's do some harder examples here. So find the derivative for the following function. So f of x equals x squared multiplied by 4 minus x. So we need to be able to figure out what f dash of x is. Remember, that's what the derivative is called. This thing here is called the derivative. Now the idea is, if we look at this function here, we've got an expression here, x squared, and we've got an expression here as well. And they're multiplying, which is a problem. But if we expand the brackets, suddenly our thing that's multiplying here is going to turn to just subtraction. So if we just expand these brackets, we're going to get 4x squared minus x cubed, and subtraction is okay. It's similar to plussing. And the way that we do this one is pretty much we can just keep that constant. The x squared is going to change to 2x. And the x cubed is going to change to 3x squared. Make sure you bring your negative down, because that's like a constant. That's like a -1. And then expanding these brackets, you get 8x here, and here you're going to get minus 3x squared. So that's your final answer there. Next one, find the point on the graph f of x equals 3x minus 2x squared. So this is our graph. This is going to be a parabola where the tangent is horizontal. We need to find the point where the tangent is horizontal. If the tangent is horizontal, that means the gradient is 0. We want to figure out where our gradient becomes 0. So the idea is, we've got our function. You want to find the derivative, because this is all about figuring out gradients at different points. So if we differentiate 3x, that just becomes 3. And if we differentiate 2x squared, that becomes minus 4x. And so that's going to be our derivative. Now, this tells us this gives us values for gradient. We want our gradient to be 0. We want f dash of x to be 0. So we're literally going to change this thing to a 0, because we want our gradient to be 0. So that means 3 minus 4x equals 0 is the equation we got to solve. And we get that x is equal to 3/4. That means that when x is 3/4, we're going to have a gradient of 0. Now we got to figure out the point where we've got that gradient of 0. We know that x is 3/4. We now got to figure out what the y coordinate is to get the whole point. We got to put this value of x into the original function and figure out what our y value is going to be. So change our x in our original function to 3/4. We get 3 lots of 3/4 minus that, shove that in a calculator, and you get 9/8. So therefore, when x is 3/4 and y is 9/8, that's going to be a point on our line, and at this point, the tangent is horizontal. Hope this helps with the questions. Good luck.